Hi guys, so this video is about how to design guttering, and there's 4 key criteria facts in this. Enjoy. Sorry it's a really boring topic, but you've got to know how to do it if you're going to be a professional. So first thing you've got to do when you're sizing guttering is calculate the effective roof area, and here we have the formula, so it's dead simple, dead simple. Here we go in finer detail. Get the length of the roof, half the width, and the height. Next, half the height, add it to half the width, times it by the length, and that will give you the effective roof area. So the next design factor is the angle, the pitch of the roof, because the pitch of the roof, that can affect the speed and the pace of the rainwater and how aggressive it comes out. So here's the surface. So let's take, for example, we've got a 45-degree pitch roof. You end up tilesing it by 1.5. So the next thing to consider is the intensity. So the rain downfall is completely different across the parts in the UK. So for example, down south, it's a lot drier. Up north, when you head towards Scotland, it's more torrential rain, and that has to be considered. In our example later on, I want you to remember this formula. This is the closer version, and this is in the British standards. Next one, risk factor. So if you've got a massive downfall and the gutters can't cope, that could do damage to a dwelling and could create a risk. So for example, if it's overflowing the guttering and it's a doctor's surgery or a museum or it's got chemicals in there, it could cause a lot of damage. So we have the risk factor. Risk factor, and you multiply. So if it's normal eaves, times by 1. Public entrance, footpath, times by 1.5. If it's going to create a blockage and an issue with a spillover, times it by 2. Hospitals, work of arts, storage of chemicals, you multiply by 3. For us, we're doing 1. So, the overall factor for calculating the flow rate, and really ideally to do gutter design, you need to do the flow rate, because the problem is if you do the area, depending on the fall, where you sited in the UK, the risk factor, it might not be adequate. So this is the formula to calculate flow rates. Area times the pitch factor times the intensity times the risk. In here we're going to do an example together. So it's going to be 1 plus 3 times 14.5 equals 58. Then it's 58 times 1.5, that's the pitch, that equals 87. Then it's 87 times the intensity, which comes to 1.74. 1.74 times 1, that's the risk factor, equals 1.74. That's the flow rate.